Okay, let's begin today's class. So good afternoon, ladies and gentlemen. Today we have our first real experiment, the force table. So now please open your book 10 to page 105. Today we do the experiment BA force table. So first I have a question for you. How many of you already read this book? Please raise your hand. 1, 2, 3. That's great. Okay, before we start the experiment, I want to emphasize some element of today's experiment. First, we have a new idea about vector. So this vector is a very fundamental idea in physics. A vector means a quantity which have both magnitude and directions. So like force is a typical vector. We have two representation of vector. One is in Cartesian coordinates, which means you need to decompose the force to Fx and Fy. And you can find the formula on page 107. So it is formula 3 and 4 and 5. It's very important formula. Another representation of vector is in another representation is you can just put the magnitude of the vector and the angle of the vector. So for this second. Yes.
Change this into.
Yeah, this is one of your months of birth.
So that's 3.
Yeah. So you times 3 is 9. So to 14. Yes.
So
14 to 14 degrees, and you make this scale to point to 14 degrees. Okay, so this is your theta 1, and
that's 242.
yes, and you need to find your F2 and theta 2. Since F1 you already required by the lab manual to put a certain amount of F1 in this blind, and your experiment is to find what is F2 and theta 2 that can balance this force table. Okay. Yes.
For force 2, okay,
Yeah.
would we say it's a negative 3 because it's the opposite side? Because right here, we're using that equation. But here is just the mass, but when we're actually doing calculations, do we have to say force 2 is a negative?
For here, you just keep the values here, yeah, because this is a polar representation,
Right,
not the
right.
Cartesian representation. Yeah. So you just keep this too. But however, for here, you can see on your next some, yeah. So you have the next one. For here, you need since it asks you to decompose the force to Cartesian coordinates.
Right.
Then you need to keep in mind there might be a minus sign before the force, but here it's just all positive.
Okay, yeah, here's all positive. So
Yeah.
down here, it might be negative.
Yeah, might be.
Okay.
Okay, please be careful to balance your force table. You need to make sure your center ring do not touch any part of your metal stick. Okay? Yes.
I was just moving this out with drum.
Yeah, that's a great idea you invented. Yeah, it's actually work.
All
It's
right.
balanced perfectly.
Sweet.
Will be according to Newton's second law, the force is m times a, which is the m times v squared over r. So here, be careful to distinguish the small m and the capital M for this experiment. Now please turn to page 136. The small m refers to the mass of the test object. And the capital M is the mass of hanger plus the hanging mass. So be careful to understand the difference of these two mass. Any questions now? Please raise your hand. No? Okay. And so you need to find another important thing is the period time t. For the period time t here, it is used to calculate the velocity of the mass. So the velocity of mass is 2 pi times r over the period t. So now I ask every group to have a group member come here. Now, please. Well, yeah, you just, for example, it's a little more than 0.1, and you can see their scale for this side and this side, right? Yeah. And these two scales, there should be one line in upper part matches one line in lower part.
So this would be like...
Which one do you think? Yeah, not exactly, but as
looks like
the
0.1.
better. Yeah, 0.1, and which line of this matches lower part? You do not need to find the exactly match, but just the best match.
Oh, it looks like it's on the 0 there.
Let's see. Yeah, it's a little more, okay.
So it would be 0.10?
No, as far as I believe, it's the 6
Wait,
here
why is it
match. You can see the 6 matches this. This two line is almost match.
Oh, you have to look for the match?
Right. Does it?
Yeah, it looks like the 6 would be...
Yeah, so you put the 6 as the next reading. So it's 0.1.
0.6?
No,
Oh,
0.16. Yeah.
Centimeters is this?
Millimeter.
Millimeters? Okay.
Charlie, which is the wire that they're talking about? Is it this thing?
No,
this little wire?
little wire, like piano wire.
So does it run like longer, or is it just this little part right here?
You just read this thing, read this caliper.
Oh, you just read this?
Yeah,
So
read
it's gonna.
this.
This is gonna change.
Yeah, this will.
Not that wire. Oh.
Not that wire.
Okay.